Hello, hello, and welcome back to another exciting, action-packed, fun-filled, tear-jerker, emotionally grabbing, heartfelt video all about environmental science and agriculture and irrigation, watering of plants, and so much other cool stuff that we are going to get into in 3, 2, 1. Boom. Here we are. So, guys, welcome back. Here we go. Let's dive right into this PowerPoint. Today, we are going to be going through slides 16 right here through slides 24. And yes, there is a video in there, so I will link that up at the end of the document or at the end of the presentation. So without further ado, let's jump right into soil conservation efforts. The U.S. in 1935 enacted the Soil Conservation Act. It was established established the Soil Conservation Service Act. Today it is called the Natural Resources Conservation Service. And what that basically looks at is conserving the soil and all the nutrients and minerals in it. Farmer-centered agricultural resource management program, that is a mouthful. Instead, we just call it FARM. Kind of poetic, don't you think? I mean, it's kind of what it is. It's a United Nations effort that focuses on resource challenges in developing nations. All right, so these are ways that the US and United Nations are looking to kind of preserve soil, to make sure that soil and its nutrients and its minerals lasts for a long, long time and is replenished. That way we don't undergo erosion. That way we don't undergo desertification. So we're all doing this to preserve the dirt. So let's keep looking on. We're going to jump here into types of irrigation, and that's the main point of today's video, all about irrigation. Now, irrigation means watering of plants. When you have a garden outside, I know you can't see outside, but trust me, there is an outside out there. And you water your crops, your plants, you are irrigating them, okay? Irrigation is to water. It's a couple different types of irrigation. We could break those down into either surface irrigation right here or subsurface irrigation. And the only type of subsurface irrigation that we deal with is subsurface drip, which basically means they bury a tube in the ground. The tube has little pinholes in it, and little drips of water go in and out. Little drips of water are pushed out, and those irrigate or water the plants. Surface irrigation, it's a little bit more in depth. We can have flow or lift. We can also have flood, basin, furrow, check basin, sprinkler, or drip. Different type of drip than subsurface. This is buried, this is on the surface. Now, of these, we're not going to go through all of these. We're going to go through a couple main ones in a little bit more detail, and we're going to look at how effective they are, maybe what could they be used for, how are they used, and maybe where would we use them. So let's keep it on. So the first one we want to talk about is furrow irrigation. So it's the oldest type of irrigation. It's the easiest and most inexpensive. Moisture is provided to the plant roots, and it's about 65% efficient. Now, there's a lot to unpack right there. So let's take a look at these pictures to the right of your screen. If you see the top one, we see our plants, our lettuce plants, our spinach plants, our greens, and in between those rows, we have our furrow irrigation. So what's happening now is essentially we've dug trenches. Trench irrigation. We've dug trenches, and now we're filling those trenches with water. The water is now going to seep into the ground and reach the roots of the plants. Okay, this is what furrow irrigation is. Now, why do you think it's only 65% effective or efficient? That's only about 15% above half. What do you think's going on there? Why is it not more efficient? I'll give you a little time. Feel free to pause the video. The reason it's not more efficient is because there's a large surface area, okay? There is a larger area for evaporation to occur. And when evaporation occurs, that's more water going into the atmosphere and less into the plant roots. So that's kind of why it's only 65% efficient. You can see on the bottom, this is a lettuce farm, and they're growing on both sides of the mound, and the furrows are in between, and they're being watered by furrow irrigation. Okay. The next type of irrigation I want to talk about is flood irrigation. And this is similar to furrow. The only difference is in furrow, we're going in between. In flood, we're flooding the entire field. So basically, you flood an entire field with water. The water soaks in evenly across the field. It's more efficient than furrow because you're not segregating certain areas to get wet. With furrow, you had those dry spots. With flood, you're just flooding everything. Everything's underwater. It's about 70 to 80% efficient. However, since you are watering more of your land, you're going to have weeds that grow on more of your land. So it will promote more weed growth. So there's your pluses and your minuses with everything. Our next type of irrigation will be spray or sprinkler, and this is probably one that you're very familiar with. This is like if you were watering your lawn, you would set up a sprinkler, you know. Feel free to play and replay that. It's probably very funny watching it on the other end. One more time. Right? Pretty cool. So this is a very, very common type of irrigation for fields. Water is sprayed or sprinkled through the air. It's the most expensive. We'll take a look at that in just a second. It's the most energy use, and so far it is the most efficient that we've covered, 75 to 95% efficiency. Now, why is it the most expensive? Well, think about it. In the previous two examples, furrow and flood, there's been nothing. We've essentially dug holes or ditches and flooded those areas or flooded an entire field. There is no technology. You basically have dirt and water. Here, though, there's more technology. And you will see from a video that I will link up later on how much actually goes into this. But you can see there's mechanical engineering that goes into this. There are pipes and a whole labyrinth of water distribution stations. Also, many of these are controlled by GPS, or they have motors on them that allow them to move extremely, extremely slow. They may be on timers. You have to get the water out to these fields. So it is more technologically advanced than just flooding a field or digging a ditch. More energy use, meaning we have to have energy to pump that water there. We have to have energy to run the motors on these large, on the bottom picture, you see this large arm, and that arm just moves slowly, slowly, slowly in a circle. You'll actually see why in just a little bit when you watch the video, but this is the reason why many of the Midwestern farms or farms in general, if you were to fly over them, you see they kind of look like circles. It's because that's the way the sprinkler goes. So let's move on to the most effective, and that is drip irrigation. It is over 95% effective. It's a slow drip. It's a surface or subsurface type of irrigation. It reduces weed growth because the drips are pinpointed to the exact spot that the crop is. It's the least amount of water loss due to evaporation because you don't have any pooling of it. And like I said before, it's over 95% efficient, the most efficient of everything that we've discussed thus far. This is the best way to water. However, it's very difficult on large scale. This is wonderful if you have your home garden, or maybe if you're a small gardener, selling your crops on a vegetable or fruit stand. But if you're looking to have acres and acres and acres, hundreds of acres of crops, this is not the way to go. Sprinklers is more of a way to go. This is for the home gardener or the small business gardener. It's very precise. It's wonderfully efficient. However, on a large scale, it's a little bit more difficult. So we have our 4 types of irrigation: flood, furrow, drip, and spray or sprinkle. Okay. Also, please remember their efficiencies. Very important to keep those in mind. Just a little pop quiz. Which one is the least efficient? If you said furrow, then you're correct. Which one is the most efficient? If you said drip, subsurface, or surface, you are also correct. Good job, guys. Excellent way to pay attention and follow along. Just 3 more slides to go and we are done. You get to watch a pretty cool History Channel video that I will link up at the end. And in fact, it is this video right here. So water conservation in agriculture. Most of the water loss in agriculture comes from evaporation. We talked about that when we talked about flood and furrow. The amount of surface area you have, more surface area means more evaporation. Loss of water also comes from seepage and runoff. So technologies that reduce these problems will go very far in conserving the amount of water that we use. Drip irrigation systems offer a promising step towards conservation because, remember, we're only letting out a very, very small amount of water at any given time. So the amount that we're losing through evaporation is very, very small, slim to none. They deliver small amounts of water directly to the plant roots. It's very precise. It's right to the roots. We're not flooding a field and hoping that all the soil soaks it up and it makes its way to the roots. No, with drip, we are concentrating those drips on the roots. Water is released to plants as needed at a controlled rate. And that irrigation video down there will concentrate a little bit more on spray and sprinkler irrigation. But it is a pretty cool video, and I do encourage you to watch it. Moving on, soil salinization. Now remember, salinization kind of looks like salt in the front, and that is actually where the soil will build up salt. Now, how does soil build up salt? Well, if you're reading along, too much or carelessly timed irrigation can actually waterlog crops and lead to salinization, a buildup of salts in the upper soil horizon. So what exactly does that mean? Well, you know that fresh water really isn't fresh water per se. It's not pure water. It does have salts in it. We need salts. When we drink our fresh water, there's salts in it. We need salts for our body. Electrolytes, right? Well, the issue now becomes if we water and water and water and water and water more plants, well, that's going to lead to more pooling of the water, which would lead to more evaporation. And you know that when evaporation occurs, the water goes from the soil to the atmosphere. But what doesn't go from the soil to the atmosphere? If you said salt, you're 100% right. The salt actually builds up in the soil while the water goes into the atmosphere. This can lead to the buildup of salts, a higher concentration of salts, and that will actually kill your plants. So there's a couple problems with watering too much. You can actually waterlog your plants, which would increase the increase the likelihood that the plant rots, right? There's too much water. Or if the evaporation rate is too high and you're watering too much, you can actually salt your plants to death. Fun fact, this is how the Dead Sea operates. The evaporation rate is higher than the amount of water coming in. So more water from the Dead Sea is being evaporated than is actually coming in. So it's leaving behind more of its salt. That's why it's called the Dead Sea, because there's such a high salt content there. So, fun fact. Not so fun if you're trying to live in the Dead Sea. I guess that's why they call it the Dead Sea. What do you think? Pretty cool, right? Yeah. All right, guys, one more slide, and that is it for the day. Salinization, it's the accumulation of salts. We just talked about this. You guys are pros at this. Salinization is a major problem in places that have low rainfall and have a naturally high salty soil. It's also where water evaporates at a quicker rate. The salts are left behind, and salinization can be slowed if irrigation canals are lined to prevent water from seeping into the soil, and if the soil is watered heavily to wash out the salt. So you want to essentially sometimes wash that salt out and get it out of there, flush it down. So I will link up a video here in just a little bit. I hope you guys enjoyed this video. Please make sure to like and subscribe to the channel. And make sure you watch that irrigation video because it will be here in 3, 2, 1. Have a great day, everybody.